So everybody, I thought I'd make a video today discussing a particular issue, and this is a response video to the, of course, first video on the Opus 23 channel. The only reason why I did this because it looks like either YouTube decided to delete my comment or the person that runs Opus 23 deleted it for one reason or another. So I thought I'd just discuss the argument that I made, the biggest one that I felt was most interesting, which was the encodings issue. His video, of course, to sum it up, was discussing um, large language models, how in many ways humans are essentially very much like large language models, meaning that they are an inference engine that takes, text and spits out a response. But of course, if you understand anything about intelligence and psychology, you know that that particular sort of interpretation is not only very wrong, it is just so out of character for what we know factually. So, getting into the weeds here, let's kind of break down my argument and why I think his interpretation of large language models is wrong. First and foremost, we need to understand what large language models are. Large language models, it's kind of in the name, are machine learning algorithms or models that will take inputs like text, convert them into tokens, and be trained on that body of text. It could be as simple as, say, the collected works of Shakespeare, or it could be the entire internet. Or it could be, say, the work of Deleuze, and I can't remember the other guy that Deleuze wrote a lot of books with. It's a lot of work. And then, once you've gone through the process of training on that data, adjusting the weights, you freeze that artificial neural network based on the training data, and then you put it up somewhere and start asking questions, like if you were doing it with Deleuze, like what did Deleuze say about XYZ? Or give me a recipe for, I don't know, tater tot hot tish, whatever, something like that if it was like the internet in general. And that is the basic pattern of it, and then it'll give you an output. Now, the important point is how do we actually convert text, images, video, what have you, data, into something that the machine can understand? Or rather, when I say understand, I should say compute on. We have to transform it into numbers. And this is important. Whenever you are encoding something, you are actually changing it. And in the case of, say, text-based large language models, by changing them into numbers, you are, of course, decontextualizing them. And we aren't just talking about, oh, whole words are turned into numbers, like, I don't know, the word the goes to 3,321, and the word, I don't know, tokenization is 1, for example. That's not actually how it works. It will break up words into smaller pieces, tokens, encode those words, or tokens really, into different numbers. And in some cases, the same word will actually be represented by different numbers in different parts of the text. Part of that is important because sometimes where words lie or tokens lie within a text gives a different contextual reference over another. And that is actually one of the biggest parts or fields of study in machine learning, is how do you fully contextualize text. We kind of sort of do okay with regard to the Latin alphabet languages, but when it comes to, say, languages like out of East Asia, where they're still using, of course, and are using pictograms, like in China and Japan, the contextual references for the pictograms will completely be missed by LLMs. It is still very far behind, and it has been a very big issue. It's one of the few things that places like China and Japan for machine learning research has been focused on, because context is very hard to infer from just the pictograms and their order. There is a lot being stated without words being shared, as it were. And alphabetical languages or phonetic languages like English, Spanish, what have you, we get away with that because of the fact that we do have a sufficient degree of context for then the machine to be able to do probability sort of analysis. And that's really the key issue here is that Opus 23 was asserting that, oh, this is just like how humans think. In reality, not really. Humans think in a different way. And in fact, living things in general operate in a fundamentally different way than what a large language model or transformer model does. Namely, that organisms respond not simply to the stimuli and then produce an output like, I don't know, let's take his cat example. It locks its eyes on a mouse and then leaps at it. It's actually thinking about, am I close enough to the target? Has it noticed me? Am I close enough to leap? Am I ready? All those kinds of things. Now, obviously, it doesn't have words like I and so forth, like linguistical. Those are just contrivances for this argument to understand that there are multiple parameters that is going on inside the brain of a cat. We even see this in much smaller, simpler organisms from our perspective, such as the jumping spider. The jumping spider, despite having a very small brain, just I think a few 100,000 neurons in size, has the ability to have a 3D map constructed in its head so that it knows the best potential point of attack to a potential prey or routes of escape and so forth. Literally, they just do it like that. It's just automatic. That evolutionary pressure for them to be able to have that kind of mental map of their environment, which, by the way, mice also do have. That's one of the things about the cognitive revolution that people don't know. That's why the mice maze thing shows up a lot in tropes about psychologists in their laboratories, because that was how we cracked the code with regard to mental maps in mammals like us, is literally mice mazes, where we would take one part of the maze that had peanut butter and the mouse's sense of smell would, oh, it's in this general direction. And we would let it get to the peanut butter and num 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 eat it. And then we would change up the maze where we close off the route that would allow the mouse to get there maybe a bit further away. So it's not just a direct path. And then open up another path. And then, of course, that was close enough that the mouse knew mentally, yeah, that's the direction. That's where I should go. The only way a mouse could, of course, do that is because it has a mental map, a model of the maze, rather than simply responding simply to stimulus and pattern matching, as Opus 23 would try to argue. And that is, of course, the important part about intelligence. Intelligence is not simply creating outputs that match to a pattern. It is understanding what the pattern is and what is the underlying, creating an underlying model from which to infer like what all that means. I mean, literally, that is where current machine learning is going. It's called the world model theory, which is why they talk about large language models having only a world model for text, and thus they can't understand, for example, what an apple is, because if you said rotten apple, fresh apple, they're both apples, but to large language models, because of the way they do things, which is the encodings, they are not the same. Fresh apple and a rotten apple are two different entities or two different kinds of text and categories. But to the human being and to, of course, many other organisms that make a distinction based on sense of smell and whatever other traits that we can discern fresh apple from rotten apple, they are, of course, the same, but we know one's off. And this is, of course, the key issue with his entire argument, which is that encoding matters, but he doesn't think that it does. I think it's probably because he doesn't have a degree in computer science, but we're still, you don't even need to have a degree in computer science. You can literally go to chatgpt.com, ask them, like, how do large language models work? And then, of course, you can ask the next question, How does, what was it? What was my next question? How is text encoded for large language models? Those are two questions you can ask ChatGPT for free right now without logging in, and it will explain it to you. But Opus 23 wants to go and sound profound rather than sound and be mundanely, I don't know, relevant, boring. And that's kind of why I've had to make this video, because this is the kind of behavior that I see on BreadTube or BreadTube adjacent video essayists that fundamentally breaks the mold with regard to fact versus feelings. And I hate using that phrasing, but it is what it is. He's working from the feeling that, well, I feel it's this way. And I'm like, do you have evidence to back that up? Do you have any citations? By the way, his video has no citations for anything he's talking about, which is absolutely disturbing. Um, I'm not going to nitpick on the audio levels and all that other stuff. I think a ton of people have already told him, hey, bro, fix your audio levels. But this is the biggest issue with his entire thesis. Everything else, the concept, vision, the whole talking about how people interact with each other, that's window dressing. Doesn't get to the core of the argument about intelligence. And more importantly, it misses the mark greatly. Intelligence is not pattern matching. This is well, this has been well established. It's not simply that. If it was, then rote rehearsal should be able to teach everyone to become a physicist. But the reality is, it doesn't. Same thing with like rote rehearsal doesn't really teach you to be a good mechanic either, or a good cook. There's so many steps and mental maps and models that you have to use in the world to be able to achieve just a modicum of functionality, whether it's in the act of like STEM sort of stuff or just doing office work. You're building a mental map of your world. You're building a mental map of other people. You're building a mental map of yourself. And these maps are changing and transforming all the time. Not simply to new information from the outside, but new information from the inside. New insights found from self-reflection and reanalysis and deconstruction. These things are not acts of a machine. These are acts of a much larger multi-layered process, right? A cybernetic system, as it were. And that in itself is, I think, the thing I can leave you all with, rather than continue to blather on. So, anyways, Opus 23, please don't delete people's comments just because you disagree with them. Actually respond. If you can't actually respond to the question of encodings and whatnot, I don't know what to tell you. Um, Go read a little bit. I mean, I'm not like a person that's read Deleuze or any of those kinds of people. I just reference them because, I'm starting to read him. uh, so, anyways, don't be a chicken, Actually address issues like this. Make a response video. Come on.